This is the EdExcel GCSE 9 to 1 Maths Higher Paper 1 from the November 2022 series, and this paper is a non-calculator paper. Question number 1. We have to write 500 as a product of powers of its prime factors. So we begin with this 500. Now this 500 we can split up as 250 multiplied by 2. 2 is a prime number, 250 is not a prime number, so the 250 we can further split up. We can further split the 250 as 125 multiplied by 2, and then we still multiply by 2. The 2 is a prime number, the 125 is not a prime number, so we can further split up the 125. 125 can be written as 25 times by 5, and then we still multiply by 2, and then multiply by 2 again. Now, the 5 is a prime number, the 2's are prime number, the 25 is not a prime number, so the 25 we can further split up as 5 times by 5, and then we multiply this by 5, multiply by 2, and then multiply by 2. So now we can write 500 as the product of powers of its prime factors. We have 2 squared, that comes from 2 times by 2, multiplied by 5 cubed, that comes from the 5 times 5 times 5. So we have 2 squared times 5 cubed. Question number 2. For part A we have to work out 1 3/5 plus 2 1/4, and we have to give our answer as a mixed number. We need to approach this question by converting these mixed numbers into top-heavy fractions. So, the 1 3/5, if we convert that into a top-heavy fraction, well, we've got the 1 times by the 5, we add on to this the 3, we divide that by 5. Then we add. Now, the 2 1/4, to convert that into a top-heavy fraction, we've got the 2 times by the 4, we add the 1, and then we divide that by 4. So now let's simplify these results. 1 times by 5 plus 3 divided by 5, that's 8/5. Then we add to this, well, we've got 2 times by 4 plus 1, which is 9, and we divide that by 4. We have 9/4. So we have 8/5 plus 9/4, which we need to work out. So to work this out, we've got 8 times by 4 plus 9 times by 5, and then we divide this by 5 times by 4. So 8 times by 4, that's 32, 9 times by 5, that's 45, and 5 times by 4, that's 20. And so if we simplify this even further, 32 plus 45, that's 87. We divide that by 20, and 20 goes into 87 3 whole times with 17 left over. So we have the result of this calculation as a mixed number equaling 3 17/20. For part B of the question, we have to show that 2 2/3 divided by 6 is equal to 4/9. Well, we've got 2 2/3 divided by 6. We need to convert this 2 2/3 into a top-heavy fraction. So we've got 2 times by 3 plus 2 divided by 3. And then we divide this fraction by 6. 2 times by 3 plus 2, that's 8, and then we divide that by 3. And then we divide this by 6. Now, dividing by 6 is the same as multiplying by 1/6. So we have 8/3 multiplied by 1/6. And so, working this out, we have 8 over 18, because 1 times by 8 is 8, and 6 times by 3 is 18. And we can simplify this fraction by dividing both the numerator and the denominator by 2. So we end up with 4/9, which is the result we wanted to show. Question number 3, we have to simplify 2 to the minus 5 times 2 to the 8 all to the power of 2. And we have to give our answer as a power of 2. So if we work out what this is, well, we are multiplying when we have the same base, so we add the powers in that case. So we have 2 to the minus 5 plus 8, and then this is raised to the power of 2. So we have 2 to the power of 3 to the power of 2, and when we have a base to a power to another power, we multiply the powers, leaving us with 2 to the power of 3 times by 2. In other words, we would have 2 to the power of 6. Question number 4. We have to work out 0.004 times by 0.32. Well, we can rewrite this 0.004 as 4 over 1000. Then multiply this by 0.32. We can rewrite the 0.32 as 32 over 100. So if we work this out, 4 times by 32 is 128. And then we divide this by 1000 times by 100, which is 100,000. 128 divided by 100,000, that's 0.00128. So the result of this calculation is 0.00128. Question number 5. A car factory is going to make 4 different car models A, B, C and D. 80 people are asked which of the 4 models they would be most likely to buy. The table shows information about the results. 23 want car A, 15 want car B, 30 want car C, 12 want car D. The factory is going to make 40,000 cars next year. We have to work out how many Model B cars the factory should make next year. Well, to find out the number of car Bs that the factory should make next year, well, we've got 80 people altogether, and of those, 15 want car B. So the fraction of car B is 15 over 80. And if we assume that we have a proportion of the 40,000 cars, then to find out how many of model B we want, we need to multiply 15 over 80 by 40,000. So if we work out what this is, well, 40,000 divided by 80, that's equal to 500. So we have 500 times by 15, which is equal to 7,500. So we have 7,500. Question number 6. Rizwan writes down 3 numbers A, B and C. The ratio A to B is 1 to 3. The ratio B to C is 65. For part A, for the first part, we have to find the ratio A to B to C. So we begin with the ratio A to B being 1 to 3. Then we've got the ratio B to C being 6 to 5. Now if we get the B's the same, we need to find the lowest common multiple of 3 and 6. That's 6. Now to go from the 3 to the 6 we times by 2. So we also need to multiply this 1 by 2 to get 2. And then we multiply the 5 by 1, as the 6 multiplied by the 1 gives 6. So here we would have 5. So when we come to find the ratio A to B to C, we have 2 to 6 to 5. Next, we have to express A as a fraction of the total of the three numbers A, B and C. Well, the total that will be given by 2 plus 6 plus 5. And of this, A is represented by 2 parts. So if we work out what this is as a fraction, 2 plus 6 plus 5 is 13. So our fraction is 2 over 13. Next, Emma writes down three numbers m, n and p. N is equal to 2m and p is equal to 5n. We have to find the ratio m to p. Well, if n is equal to 2m and p is equal to 5n, what we can see from here then is p is equal to 5 times by 2m. So we have p equals 10m. So when we come to find the ratio m to p, well, what we can say is the fraction m over p, that's equal to 1 over 10, which means the ratio m to p is equal to 1 to 10. So we have our ratio being 1 to 10. Question number 7. A storage tank exerts a force of 10,000 newtons on the ground. The base of the tank in contact with the ground is a 4 meter by 2 meter rectangle. We have to work out the pressure on the ground due to the tank. So the first thing to do is calculate the area. If we work out the area, we'll call the area A. That's equal to 4 multiplied by 2. And if I work out what the area is then, 4 times by 2 is 8. The area is equal to 8 meters squared. Which means when we come to work out the pressure is equal to the force, which is equal to 10,000 divided by the area of 8. And if we work out what this is equal to, 10,000 divided by 8 is 1,250. Our units will be newtons per meter squared. We've got 1,250 newtons per meter squared. Question number 8. Two numbers m and n are such that m is a multiple of 5 and n is an even number, and the highest common factor of m and n is 7. We have to write down a possible value for m and a possible value for n. Well, let's focus on m to begin with. We've got multiples of 5, so we've got 5, 10, 15, 20, 25, 30, then we've got 35, 40, 45, and then 50. And we could continue on. And then we've got n, which is an even number. Now if I write down even numbers, in other words, multiples of 2, we've got 2, 4, 6, 8, 10, 12, 14, 16, 18, and then 20. We could continue. What we want is a number from both of these lists such that the highest common factor is 7. Now if I look with the set of numbers for m, you can see that 35 is in the 7 times tables, and if I take a look at the numbers belonging to set n, 14 is also in the 7 times tables, and this will be the highest common factor of both 35 and 14, that's 7. So the highest common factor of both m and n is 7, which means m is 35 and n is 14. Question number 9. For part A, we have to complete the table of values for y equals 6x subtract x cubed. Well, when x is equal to minus 2, y is equal to 6 times by minus 2 subtract minus 2 cubed. 6 times minus 2 is minus 12. Then I've got minus, then minus 2 cubed, that's minus 8. So I've got minus 12 subtract negative 8, so that's minus 12 plus 8, that's equal to minus 4. So when x is negative 2, y is negative 4. When x is equal to negative 1, we've got 6 times by negative 1, subtract negative 1 cubed. So I've got minus 6 minus minus 1, so that's minus 6 plus 1, which is minus 5. When x is 0, we've got 0 subtract 0, which is just 0. Then when x is equal to 1, we've got 6 subtract 1, which is 5. And so here is the corresponding y values for our x values. For part B, we now have to plot those values and then draw the graph of y equals 6x subtract x cubed for values of x from minus 3 to 3. Here is the graph of y equals 6x subtract x cubed between minus 3 and 3. Question number 10. Lena spins a biased 5-sided spinner 40 times. Here are her results. Lena is now going to spin the spinner another 2 times, For part A, we have to work out an estimate for the probability that she gets a score of 5 both times. So she gets a score of 5 and then she gets another score of 5. Now the probability of getting a score of 5, that's equal to, well, out of 40, the frequency of getting a 5 is 10. So we have 10 out of 40. And therefore, the probability she scores a 5 twice, well, we've got 10 out of 40 multiplied by 10 out of 40. So what we end up with over here is 1 over 16. So we have 1/16. Now for part B, Derek is going to spin the spinner a large number of times. We have to work out an estimate for the percentage of times Derek can expect to get a score of 1. Well, if he gets a score of 1, the relative frequency that will equal 6 out of 40. So what we have calculated over here is calculated the relative frequency of getting a 1, that's 6 over 40. So what we need to do is calculate this as a percentage. So if I work this out as a percentage by multiplying by 100, what we end up with is 6 times 100, which is 600. Divide that by 40, we get 15. So we have 15%. Question number 11. We've got shapes P and Q, and we have to describe fully the single transformation that maps shape P onto shape Q. Well, what we need to do is, from the corresponding sides, is draw a line, like so, and then if I extend this line even further down to say this point, and doing the same thing for the other points, what you can hopefully see then is this point corresponds with this point, and then this point would correspond to this point. We see we have a center of enlargement over here at 0, 2. And if I find the scale factor, well, this length is 1. This length is 3. So therefore, our scale factor is 1/3, which means we have an enlargement with scale factor of 1/3, and the center of enlargement will be 0, 2. Question number 12. We have to solve the simultaneous equations 5x plus 2y equals 11 with 4x plus 3y equals 6. Well, if I multiply this first equation by 3 and this second equation by 2, then 5x times by 3 is 15x. 2y times by 3 is 6y. 11 times by 3, that's equal to 33. 4x times by 2 is 8x. 3y times by 2 is 6y. 6 times by 2 is 12. So we now have two equations with two unknowns. What you will find is the sign is the same in front of the y's, and the coefficient of y is the same, which means we can subtract these equations. 5x subtract 8x is 7x, and then 33 has 12 subtracted from it, which is 21. So we've got 7x is 21, which means x is equal to a value of 3. And when x is 3, we can find the corresponding y coordinate. We can substitute into either equation. Let's substitute into this first equation. We've got 5 multiplied by 3. Then we add on 2y, and this is equal to 11. 15 plus 2y equals 11. 2y equals -4, which means y is equal to -2. X is equal to 3. Y equals -2. Question 13. P is inversely proportional to T. We have to complete the table of values. So if we have P being inversely proportional to T, we have this statement here, which we can rewrite as P equals some constant K over T. And we know that when T is equal to 100, P is equal to 1. So with this, we have 1 equals K over 100, which means K is equal to 100. So that means our formula for P is equal to 100 over T. Now when T is equal to 25, we can find out what P is. P would then equal 100 over 25, which is 4. Let's see what happens when p is 5. When p equals 5, 5 equals 100 over t. 100 divided by something is 5. That something is 20. So t is equal to 20 when p is 5. And then when t equals 2, we've got p equals 100 divided by 2, which is equal to 50. So when t is 2, p is equal to 50. Question number 14. The table shows information about the weights in grams of some potatoes, and on this grid we have to draw a histogram. So we need the frequency density to begin with. So for us to find out the frequency density, we need the class width. Here we've got a class width of 20, we've got a class width of 10, we've got another class width of 10, and then a class width of 20. So now to find out the frequencies, we need to do the frequency density multiplied by the class width. So to find out the frequency densities in that case, we need to do the frequency divided by the class width. 20 divided by 20 is 1, 50 divided by 10 is 5, 60 divided by 10 is 6, 30 divided by 20 is 1.5. So now, if we create our scales, we've got 0, 1, 2, 3, 4, 5, 6, 7. So for the first one, we've got 50 to 70 with frequency density of 1. So we've got 50 to 70 with a frequency density of 1. Then from 70 to 80, we've got a frequency density of 5. So that is from 70 to 80. And then 80 to 90, we've got 6. So that's 80 to 90, which is 6. And then from 90 to 110, we've got 1.5. So that takes us up to here. And therefore here is our completed histogram. Question number 15. The diagram shows a sector of a circle of radius 18 centimeters. That's what we see here. The length of the arc is 4 pi centimeters. We have to work out the value of x. Well, to work out the arc length, we have a fraction of the circumference. The fraction of the circumference we have will be x divided by 360, and then we multiply this by 2, pi times by the radius of 18. And the result of this calculation is equal to 4 pi. 2 times by 18 is 36. So we've got 36 divided by 360, which is 1/10. So we have x divided by 10, and the pi's cancel on both sides, leaving us with, on the right hand side, 4. X over 10 is 4, which means x is equal to 40. Question number 16. For part A, we have to prove that 2m plus 1 all squared subtract 2n minus 1 all squared is equal to 4 times by m plus n times by m minus n plus 1. Well, if we begin with what we have on the left hand side, we have 2m plus 1 squared subtract 2n minus 1 squared. And what this is equivalent to, well, 2m plus 1 all squared, that's equivalent to 4m squared plus 4m plus 1. And then we subtract from this 2n minus 1 all squared, so that is 4n squared subtract 4n plus 1. And if we attempt to tidy this up even further, well, 4m squared subtract 4n squared, that is the same as 4m squared subtract 4n squared. Then we've got 4m subtract negative 4n, so that's positive 4n. Then we've got 1 subtract 1, which is 0. And now what we have to do is simplify this even further. Well, hopefully what you will recognize is each term contains a 4. So I've got 4 times by m squared subtract n squared plus m plus n. Now you will find that m squared subtract n squared is the difference of two squares. So we have 4 multiplied by m plus n times m subtract n plus m plus n. Now do you notice how the m plus n is common to both terms? So we have 4 multiplied by m plus 1 and then what's left over is the m subtract n plus 1. And that's exactly the result we see on the right hand side. So this result is shown to be true. Sophia says that the result in part A shows that the difference of the squares of any two odd numbers must be a multiple of 4. Is Sophia correct? You must give reasons for your answer. Well, she's correct because 2n plus 1 and 2n minus 1 are odd numbers, and the right hand side is a multiple of 4. And that's because we are multiplying by 4. Question number 17. We have to work out the value of 8 over 27 to the power of 4 over 3. Well, what we can do is we can rewrite this as follows. We can rewrite this as 8 over 27 to the power of 1/3 to the power of 4. We have a base to an exponent to another exponent. When we multiply the 1/3 by 4, we get 4/3. So now we can evaluate 8 over 27 to the power of 1/3. We cube root the 8, we cube root the 27, so we have 2/3, and then this is being raised to the power of 4. Then we do 2 to the 4, and then 2 to the 4 is 16. Then we do 3 to the 4, and that is 81. So our final answer is 16 over 81. Question number 18. A and B are points on a circle with centre O, and DBC is a tangent to the circle at B. The angle AOB is x, and we have to show that the angle ABC is 1/2 x. You must give a reason for each stage of your working. Well, what we know so far is OA and OB are equal to each other. The reason for that is OA and OB are both radii. So they are both radii. And that means then that this triangle is isosceles. And because we have an isosceles triangle, this angle is equal to this angle. So OBA is equal to OAB. And that's because the base angles in an isosceles are equal. So the angle OBA, which is equal to OAB, that will equal 180 subtract x divided by 2. So that's what's shown on this diagram. Now we know that the angle of OBC, that's going to be 90 degrees. And that's because the tangent and the radius are perpendicular. So the angle we need to find out is the angle ABC. And to work out the angle ABC, we need to do 90, and then we subtract from this 180 minus x over 2. So to simplify this, what we can do is rewrite all this over a common denominator of 2. So we have 180 over 2, which is 90. And then we subtract, and we'll put this in brackets, 180 subtract x. So the 180 subtract the 180 gives 0, leaving us with minus x, which is just x divided by 2, or half x. Question number 19. You have to solve 1 over x subtract 1 over x plus 1 equals 4. Well, we've got the 1 times by the x plus 1, then we subtract 1 times by the x, and then we divide this result by x times by x plus 1. The result of this is 4. And if we simplify this, on the top we've got x plus 1 subtract x, and if I multiply through by x times by x plus 1, the right hand side becomes 4x times by x plus 1. X subtract x is 0, so I've got 1 equals 4x squared plus 4x. And if I take everything over to one side, we have 4x squared plus 4x subtract 1 equals 0. Now to solve this, we can use a variety of methods. First thing I'm going to do is divide by 4 to simplify this to x squared plus x subtract 1 over 4, and this is equal to 0. So now we can complete the square. And if I complete the square, I have x plus, and here I would have 1/2 squared subtract 1/2 all squared, and then I'm still subtracting this 1/4. And the result of this, 0. So I've got minus a quarter minus another quarter, that's minus 1/2, so I've got x plus 1/2 squared subtract 1/2 equals 0. And so if we add 1/2 to both sides, we would have x plus 1/2 squared equals 1/2, and if we now square root both sides, we would have x plus 1/2 equals 1/2 square rooted. And don't forget, when we square root, we have the plus minus with it. Now square root over half is root 2 over 2. So we have x plus 1/2 equals root 2 over 2. And don't forget, we've still got this plus minus, and if I subtract half from both sides, we can conclude x is equal to -1/2 plus minus √2/2, and that is our solution. Question number 20. Alfie has 11 cards. He has 3 blue cards, 7 green cards and 1 white card. Alfie takes at random 2 of these cards. We have to work out the probability that he takes cards of different colours. So probability of 2 different colours, well, we could have blue and green, then blue and white, or we could have green and white, or we could have this the other way around, whereby we have the green and then the blue, the white and then the blue, and then the white and then the green. Well, let's calculate these probabilities. So blue and green. So that will be 3 out of 11. Now, because I've already chosen the card, there's going to be 10 left, and then green, that will be 7 out of 10. Blue and then white, well, we've got 3/10, 3 over 11 times by 1/10. And then green and white, we've got 7 over 11 times by 1 over 10. Then green and blue, we've got 7 over 11 times by 3/10. Then white and blue, so we've got 1/11 times by 3/10. Then white and green, we've got 1/11 times by 7/10. Now, do you notice how 110 is our multiple of 11 and 10? And then we have on the top 3 times by 7, which is 21. 3 times 1, which is 3. 7 times 1, which is 7. 7 times 3 is 21. 1 times 3 is 3. 1 times 7 is 7. So now if I simplify all this, we get 62 over 110, which simplifies to a value of 31 over 55. Question number 21. The diagram shows a sketch of part of the curve with equation y equals cos x. P is a minimum point on the curve. We have to write down the coordinates of P. Well, that quite simply will be 180 and cross and 1 down. And that's because what's shown over here is a periodic curve. So this bit is a curve of cos x between 0 and 360, and then that bit is once again repeated to the 720 point. So for our coordinates, we have 180 then -1. Question number 22. Here is a triangle ABC. We have to work out the value of sine ABC, which is this angle, giving our answer in the form m over n. Now, we've got a side, an angle opposite it, angle opposite with a side, so we can use the sine rule. So if I use the sine rule, we've got the sine of the angle ABC divided by the length opposite it, which is 6.5, and then we've got sine 30 divided by 10.7. So sine 30 is a half. So we've got sine of ABC divided by 6.5 equals 1/2 divided by 10.7. So the sine of ABC, That's equal to 0.5 times by 6.5 over 10.7. So half of the 6.5, that is 3.25. So we have 3.25 over 10.7, and if we multiply both the top and bottom by 100, we end up with 325 divided by 1070, and because both numbers can be divided by 5, if we divide those numbers by 5, what we end up with is 65 divided by 214. So this is our simplified value for sine ABC. Question 23. Get the first 5 terms of a geometric sequence: root 5, 10, 20, root 5, 200, 400, root 5. For part A, we have to work out the next term of the sequence. Well, if we call the common ratio r, we can find r by dividing successive terms. So we could do 10 divided by root 5, and this is equal to 20 root 5 divided by the 10. And if I work this out, r is equal to 2 root 5, because the 20 divided by the 10 gives a 2, we still multiply by the root 5. So to work out the next term of the sequence, what we would have to do is take this 400 root 5 and multiply that by 2 root 5, and working that out, 400 times by 2 is 800, root 5 times root 5 is 5, 800 times 5 is 4000. So we have 4000. Next, the fourth term of a different geometric sequence is 5 root 2 over 4. The sixth term of the sequence is 5 root 2 over 8. Given that the terms of this sequence are all positive, we have to work out the first term of this sequence. You must show all your working. Well, for a geometric sequence, we've got un equals ar to the n minus 1, where n is the position. So for the fourth, we've got ar to the 4 minus 1, that's equal to 5 root 2 over 4. And for this, what we can conclude from this then is ar to the 3 is equal to 5 root 2 over 4. For the sixth, we've got ar to the 6 minus 1, that's equal to 5 root 2 over 8. And if we simplify this, ar to the 5 is equal to 5 root 2 over 8. To find out what a is and what r is, well, what we can do is divide these equations. So if I call this first equation 1 and the second equation 2, if I do 2 divided by 1, well, I've got ar to the 5 divided by ar cubed, that's equal to 5 root 2 over 8 divided by 5 root 2 over 4. So I can simplify all this. The 5 root 2's cancel. I've got an eighth divided by a quarter, which is a half. So I've got r squared, because the a's cancel here, and r to the 5 divided by r cubed is just r squared. So I've got r squared equals a half, and taking the square root, I end up with r equals root 2 over 2. So I've got a times by r cubed. Now I know what r is, that's root 2 over 2, and that's equal to 5 root 2 over 4. So a times by, now root 2 over 2 all cubed, that's root 2 over 4, and this is equal to 5 root 2 over 4. The 4's cancels, the root 2's cancel, leaving me with a equals 5. So I've got a equals 5. Question number 24. Here is a solid sphere and a solid cone, that's what we see here. The volume of a sphere is 4/3 pi r cubed. The volume of the cone is 1/3 pi r squared h. All measurements are in centimeters. the volumes of the sphere and the cone are equal, we have to find the ratio r to h in its simplest form. Now if the volumes are equal, that would mean that 4/3 pi r cubed equals 1/3 pi r squared h. Now the 1/3s cancel and the pi's cancel, so I'm left with port r equals h. I want to find the ratio r to h. If I work out r divided by h, I end up with a value of 1/4, which means the ratio r to h is equal to 1/4. So we end up with r to h equaling 1/4. For part B of the question, here is a different solid sphere and a different solid cone. We've got the surface area of the sphere being 4 pi r squared, and the curved surface area of a cone is pi rl. Measurements are in centimeters. We have to find the surface area. Well, the surface area of the sphere is equal to the total surface area of the cone, and we have to find the ratio r to h. Well, we already know what the surface area of a sphere is. That's 4 pi r squared. The surface area of the cone, that's equal to, well, I've got the curved bit, pi rl, but then I need to add on to this the circle at the bottom. That's pi r squared. Now, the problem is, I've got this L over here. I don't want an L. I want a H here. So what I can do is define the height of the cone to be H. And actually, we can find out what L is using Pythagoras. So, L is equal to, through Pythagoras, r squared plus h squared square rooted. So now I can replace the L with r squared plus h squared all square rooted. So therefore, the surface area of the cone, we would have pi r times by the square root of r squared plus h squared plus pi r squared. So what we need to do is set this 4 pi r squared equal to this result here. So we've got 4 pi r squared equals pi r times by square root of r squared plus h squared plus pi r squared. And what we need to do is simplify this. Well, if I subtract pi r squared from both sides, we would have 3 pi r squared equals pi r times by r squared plus h squared square rooted. Now the pi's cancel and one of the r's cancel, so we have 3r equals r squared plus h squared square rooted. Now we can square both sides, so we have 9r squared equals r squared plus h squared, because 3r times by 3r is 9r squared. So 8r squared subtracting r squared is equal to h squared, and if I divide by h squared and then divide by 8, r squared over h squared equals 1/8. And if I square root both sides, I've got r over h equals 1 divided by square root 8. Which means the ratio r to h is equal to 1 to root 8. So that is the required ratio.